Assalamualaikum and hi. Now we are going to present to you about applied maximum and minimum problem. The topic overview for this presentation is an introduction about applied maximum and minimum problems, steps on how to do the applied maximum and minimum problem statement, and problem solutions for the applied maximum and minimum problem, and lastly, conclusion on this topic. So now, for the introduction of applied maximum and minimum problem is, many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such functions will determine the domain from which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value, the extreme value theorem, the first derivative test, or the second derivative test. Next are the steps on how to do the applied maximum and minimum problem. The first step, find the derivatives. The second step, let the derivative equal to 0 and find the value of the variable. And the third step is the second derivative test. If the second derivative is more than 0, then it's equal to minimum value. If the second derivative is less than 0, then it's equal to maximum value. Over here, we have the problem statement on applied maximum and minimum problem. Figure below shows a piece of wire of length 200 cm is bent into the shape of a triangle ABF and a rectangle CDEF as shown, given that BC equals to DE. Our first problem statement is A. Express X in terms of Y. The second problem statement is B. Show that the area A cm square enclosed by the wire is A equals to 378y minus 12y square. And the last problem statement is C. Find the maximum area enclosed.
Problem solution. For equation A, we need to express x in terms of y. From the question, the value of perimeter is 200 cm. As we know that, the formula for perimeter is the sum of all the sides. So, we have to put all the value in the formula. So, it will be 7 plus 3y plus in the bracket x plus 8 plus 3y plus x plus 8 plus x equals to 200 cm. 3y plus 3y will get 6y and x plus 8 plus x plus 8 will get 2 in the bracket x plus 8. And then we expand 2 in the bracket x plus 8 will get 2x plus 16. And 2x plus x will get 3x. And 16 plus 7 will get 23. So it will be 23 plus 6y plus 3x equals to 200. Next, we bring 23 to the right hand side. So we'll get 6y plus 3x equals to 177. And then, back to the question, we have to express x in terms of y. So we bring 6y to the right hand side and we'll get 3x equals to 177 minus 6y. And then we bring 3 to the right hand side. It will be x equals to 177 minus 6y over 3. So next, we simplify 177 over 3 will get 59. And simplify 6y over 3 will get 2y. So the final answer will be 59 minus 2y. For equation B, we have to show the area that enclosed by the wire is equals to 378y minus 12y square. If we take a look from the question, we'll see that the area is a combination of two shapes, which is triangle and rectangle. In order to solve this, we need to separate it into two parts. Then, we have to find the area for triangle and area for rectangle. So then, to find the total area, we have to add the area of rectangle with area of triangle. So to find the area of rectangle, the formula is 1 over 2 times width base times width height. So 1 over 2 times width x times 6y, it will be x times 6y over 2. So 1 over 2 times with x times 6y, it will be x times 6y over 2. The value of x is 59 minus 2y times with 6y over 2. We expand it and we'll get 354y minus 12y squared over 2. We simplify 354y over 2, we will get 177y. We simplify 12y squared, we will get 6y squared. So the area for triangle is 177y minus 6y squared. To find the area of rectangle, we have to multiply length and width. Length is x plus 8 and the width is 3y. So it will be 5y minus 2y plus 8 times with 3y. We expand it and we'll get 170y minus 6y squared plus 24y. So the area for rectangle will be 201y minus 6y squared. To find the total area, we have to add area of triangle with area of rectangle. So 177y minus 6y squared plus 201y minus 6y squared. So the area enclosed by the wire is 378y minus 12y squared. We can show that area enclosed by the wire is equals to 378y minus 12y squared.
Okay, so for question C, the question asks us to find the maximum area enclosed. So we have the area which is 378y minus 12y squared. So the first step is to find the derivative for the equation just now. So differentiate 378y will get us 378 and differentiate 12y squared will get us 24y. So that's the first step. The second step is to let the derivative equal to 0. Therefore, we let dA over dy equals to 0, which we can see here 378 minus 24y equals to 0. And then 378 over 24 will get us y equals to 63 over 4. Moving on to step 3, where we differentiate the equation for the second time, which will get us negative 24. Now, because negative 24 is less than 0, therefore y equals to 63 over 4 can be set as the maximum value. Therefore, to find the maximum area, we simply substitute 63 over 4 into the area's equation. Then we will get 11,907 over 4 as the answer. Okay, so the conclusion for this is that at the end of the video, we can understand that problems often involve restrictions and sometimes neither the problem nor the constraints are clearly stated. Therefore, we can use calculus or other mathematical techniques to solve these maximum/minimum problems. We need to understand the situation at hand and translate the problem into mathematical form. In conclusion, when using applied maximum and minimum problem, we achieve on how to examine some problems that require understanding, translating it into mathematical form, solution, and checking. Lastly, here are the references used in this video. Right, so that is all from us. Thank you for watching.
Happy